This project was an offshoot where we looked at 3 different pain tests and we compared it in 2 different rat models, specifically genetic backgrounds. We have an outbred Sprague Dawley and an inbred Fischer F344, which kind of sparked this project in this paper.
Welcome to The Last Word, the official JAALAS podcast dedicated to connecting and informing the laboratory animal science community. Each episode takes a closer look at recent articles published in our journals, JAALAS and LAS Pro, and features interviews with professionals advancing the field. I'm Jennifer Smith, your host. As a laboratory animal veterinarian and the Director of Education and Scientific Affairs at JAALAS, I look forward to sharing these conversations with you. Let's discover something new together. Hello, with me today is Dr. James McNew, or James or Jamie, is a new friend. He's also the Clinical Veterinarian at Baylor College of Medicine. Jamie recently completed his Comparative Animal Training Program at the University of Missouri-Columbia, and he also completed his vet school training at Texas A&M. And today we are going to talk about his very exciting new paper in JAALAS, and that is titled Comparison of Thermal and Mechanical Pain Testing Modalities in Sprague Dawley and Fischer 344 rats. Jamie, I am so excited that you're on the podcast with me today, and I cannot wait to hear about this paper, and I can't wait to hear more about you. So take it away. Tell us a little bit about yourself.
Yeah, thanks, Jenny. It's great to be here. I'm really glad to be invited to do this. I think it's an awesome opportunity. So as you mentioned, I went to vet school at Texas A&M, which is where I actually really learned what lab animal medicine was for the first time. I never really knew the field until we had a class where we actually were talking about different things veterinarians can do. And lab animal medicine was one of the topics that came up. So I kind of just put it in my back pocket of potential career option because I've always been interested in research and I've always been interested in how human and animal health is interrelated. But I wasn't really sure on what direction I wanted to take that. I like large animals, so I was thinking maybe a food animal practice, something along those lines, but I wasn't really sure. It wasn't until that summer after my first year, I did the veterinary scholars, research program. And as a part of that, I actually went with my mentor and helped him in Germany for a swine model for pancreatitis. And at that point, I was working with pigs is great. I love this. This is so cool. I think I want to continue pursuing this. And then after my second year of veterinary school, I went to Penn State Hershey, to the medical college there, and as well as the University of Missouri, and did 2 externships solely doing comparative medicine or laboratory animal medicine. And at that point, I was this is what I want to do. I definitely want to do a residency. So from there, I did more externships to get more exposure. But, specifically to this project, as I went through vet school, when I was getting more exposed to the field of comparative medicine, I became more interested in animal models and animal model development. So this project itself actually came off as a little bit of a side project from a larger project I was helping with. We were making a rat model to study specifically how one opioid may get metabolized differently with different enzymes in the liver. So we were knocking some in and knocking some out to really get a feel for how this might change the metabolism as it relates to humans. And we were kind of thinking, well, if we're going to study the effects that these opioids have looking at pain control, we need to find a pain test that could help do this. So this project was an offshoot where we looked at 3 different pain tests and we compared it in 2 different rat models, specifically genetic backgrounds. We have an outbred Sprague Dawley and an inbred Fischer F344, which kind of sparked this project in this paper.
Wow. I love hearing that. And I definitely want to jump in and talk about the paper, but I really wanted to just backtrack to your background. I'm so thankful to hear that you had all these really great lab animal experiences before even sort of deciding. And I just think that's fantastic. I think it's so nice to see the sort of newer generations have some of those opportunities, especially to go to Germany with pigs. That sounded like that must have been a lot of fun and a lot of hard work, I'm sure. And I'm just so glad that you were able to share that. I think it's really fun for our listeners to hear how people get into lab animal, and I think sometimes folks just assume we just kind of ended up in these careers, but most people have a pretty circuitous route to get here. So thanks
Yeah.
for sharing that. Yeah.
I mean, not to totally get too off on a tangent, but the project in hindsight is the circumstances of it are kind of funny because my mentor, he's an internist and, an expert in pancreatitis, but he actually would invite vet students who helped him in the lab to do the anesthesia. So really, I was there to help with anesthesia and learn the anesthesia. And talking to him about drugs, he was like, I forgot all this stuff after vet school. He was like, I don't know what ketamine does anymore. And so he's like, that's what I bring you here for. So it's just kind of funny, the things that you kind of get exposed to and what that kind of snowballs into.
Absolutely. I think having those opportunities, and I think you're a great testament to making the most of those opportunities as well. So I'm so glad that you shared that. All right. Well, let's talk about the paper because this is a good one, you guys. So I think you kind of briefly talked a little bit about the paper, but it would be great to hear about the team, kind of why you guys took this on, who's on the team, who did what. That's always really helpful for our listeners as well.
Yeah. So I'll start first with my research mentor at the University of Missouri. She was also my master's advisor, and that's Dr. Elizabeth Brida. She's the director of the Rat Resource and Research Center, as well as the director of the Animal Modeling Corps at the University of Missouri. So that's an internal core that makes a bunch of animal models. They do outside contracts as well, but they do a ton of work for researchers on campus there. And then Dr. Daniel Davis, he was on my committee for my master's. He's the assistant director for the AMC, so the Animal Modeling Corps. And then Dr. Kristen Grimsrud was one of our collaborators. She proposed the project that we were working on, looking at the liver enzymes and opioids and how those different enzymes are affecting the analgesic effects of them. And she's at the University of California, Davis. So all of us together kind of came up with this project to be, honestly, at first it was meant to just be a little small project that I could do for my first year of residency, maybe get a paper out of it, but the goal was to have something that I could present at the National JAALAS meeting and also write a little Phi Zeta grant, which is just a little veterinary scholars chapter.
You know what? That's so funny, Jamie, because there are so many people, myself included, that were on those grants. The more and more guests I have on the podcast, I can't tell you how many people got a start or a pretty big leg up from doing that type of research. Yeah. So welcome to the club. I am so thankful and so encouraged to hear that that's still going on as well, because I think it's launched a lot of lab animal research careers. So yeah, that's great.
Yeah. So the small grant that I wrote for internal use at the university kind of became this project that I don't want to say that I drove myself because we all worked collectively together to conceptualize it, but I was the one who performed the pain testing we did. And then once I had the data, I analyzed it, but then we collectively all went over it together where we eventually, wrote the manuscript and submitted it to JAALAS.
Oh, that is fantastic. And what a great way to learn as well. It's hard when you're new at research, and it sounds like you have amazing mentors that were willing to take that time with you and walk you through the steps. That's fantastic.
Yeah, I think for me, this was, I've worked on a lot of different research projects, and many of them unsuccessful is probably not the best way to put it, but definitely research doesn't always go according to plan. So to kind of see this project from start to finish, do the whole process of me driving, writing it up and everything and getting it submitted, my mentors were always there to help me and assist me however I needed it. And, we met regularly to maintain my forward progression, but they definitely were like, hey, this is yours, like make it your own. And then that made me feel like I got a lot out of it.
Oh, that's amazing. Like, I love how you're describing this because that is how you learn, right? You're accountable, you're doing the work, but you've got this great team behind you, pushing you forward, checking in. I think that's amazing. Kudos to those mentors. And now for you to pay that forward with the next crew, that's awesome. All right. Well, Let's just jump in then. So your introduction is great, by the way, not just because I love anesthesia, but just because it was really informative. And we would love to hear more. If you could just kind of maybe take us through the highlights. You've got some really good background information in there that I think folks that are interested in analgesia maybe haven't really stopped to think through sort of the background to some of this pain testing. And I think that's so important when you jump to the end of the paper and look at the discussion and kind of try to extrapolate the results. I think sometimes we forget to really hone in on the introduction and remember what some of those words mean. So if you could take us through that, that would be great.
Yeah, absolutely. So when we were starting this project and thinking about it, we wanted to ourselves determine a pain test to use that would fit our specific needs. But we also, because we have the ability to make different genetically modified rats, we can choose the background. And when I say background, that would just be the main genetics, like the Sprague Dawley rat or the Fischer 344 rat. And we wanted to know if there was a certain level of variation when performing this test. So essentially how accurate it is. Like if we're going to pinch the foot, are we going to get a similar reaction every time when we use a certain test? But importantly, if we use that SD or that F344 rat, will we get more consistent responses? So we used 3 different pain tests and we introduced them a little bit just as there's so many different pain tests out there, but we kind of had these available from another project. So we used a mechanical, we called a nociceptive test or pain test. And so that's just like a pinch of the foot. And then the response is when it pulls away. And we call that the randosolital test. And then we have 2 thermal sources. So one's known as the Hargraves test. And that's when the light is directed at the bottom of the foot. And so when it gets hot, they pull the foot away. And then a tail flick test. There's different iterations of this, but we specifically were looking at the source of the light on the tip of the tail, and then they flick the tail away. And to not get too into the definition of pain perception in animals, what's conscious and what's unconscious, we really wanted to know just what the response was. So when we use this test and we're considering a reaction, pulling that foot away, flicking that tail, we weren't trying to interpret necessarily what that means because we were using rats that didn't have any sort of reason to be painful. So, there was no surgery model where there was an incision on the foot and now it's a little sensitive. So we're looking at the naive state of the animal. And we didn't see any papers that had described this. So we thought that this would be really good to kind of answer that question of how consistent can each of these 3 different tests be compared to each other and then compared to these 2 different genetic backgrounds.
Oh, that's great. And I love just kind of that tie-in of like, hey, we don't see this in the literature and this is kind of why we went with this hypothesis. So yeah, that's great. All right, so let's jump into your kind of methodology, study design. You already talked a little, but maybe you could give us some more information on just sort of some of your equipment, the different technology involved in some of that testing. Again, our listeners love to hear that kind of stuff.
Yeah, so I kind of mentioned we had one mechanical, so that's going to be a pressure pain test. That's the randosolital test, which if you look up a picture of it, it kind of just looks like some tongs, right? And so it just kind of, you hold it in your hand and you can pinch the foot. So you're actually holding the rat in your hand when you do that. Some people will kind of gently cup them in a towel or however you want to restrain them. I elected to use a towel to kind of wrap them a little bit, to make them a little bit more comfortable and kind of make almost like they're in a little burrow. And then we used 2 thermal tests using the same piece of equipment. We just focused it on the foot, which is known as the Hargraves test. And then we focused it on the tail, which is the tail flick test. So we looked at male and female rats, both of the genetic backgrounds, Sprague Dawley and Fischer. And we only did 1 test in 1 group, because we didn't want to have any compounding effects they could have. Like, if we pinch the foot and then we put the light on it, is that going to change the response? So to avoid that potential variable, we only did 1 test in a subset of groups, and then we repeated each test 7 days apart. And the reason we did that is because commonly 3 days to a week is an acclimation period for rodents, more so for the 3 days. But we just wanted to more or less prove or show that if we did a week between them, there wouldn't be a compounding effect or potentially a reducing effect that, oh, I kind of learned how this is. I'm not going to react as much, right? To anthropomorphize maybe the human response of you overreact to getting pinched and then you get pinched again and you're like, okay, that's not so bad. It didn't startle me. But each of these tests, when you actually actively perform them, you repeat multiple times in each session. And when you look at how people report them, and even when I was talking to some individuals about performing these tests myself, they'll commonly repeat them 5 times each session. They may remove the highest reading or the lowest reading. Somebody I talked to removed the highest and the lowest and then averaged the 3 readings for that session, which is what I elected to do. And that kind of removes some of that, oh, there's something new, like I'm going to pull away really fast. Or, maybe to anthropomorphize again, some stubbornness of, well, I'm not going to react right now. Or I'm being held, I'm not going to show fear because I'm a prey species. And we kind of did that for each of them to, get their responses. And then we use those values to calculate a variance variable. So we use the coefficient of variation because they read out in different units. So the thermal test is a readout in seconds. It's due to a time of exposure. So you set the light to a certain brightness to not injure their foot for the entire duration of the test, which is a maximum 15 seconds. And then the Raynaud-Soleto test is read out in grams. So you just pinch their foot and the maximum force you achieve is the readout. But importantly for this, and something that I was trying to find consistently described, but, having conversations with people helped more so than anything, was how do we acclimate these animals to being handled and to the enclosures that we use for these tests. So for the thermal tests, you put them in small little plexiglass squares. Someone recommended to me to do that a couple days out in advance. So that way, when you put them in this little enclosure in the room you're going to be doing this testing, they're not all excited, sniffing all the corners, walking around, investigating the space. Because if you're going to see when they pull their foot away, you're going to make sure you have a consistent response. So you want the animal to be nice and calm and just standing very relaxed. So you can turn the light on in their foot and then they feel the heat and then they pull their foot away. So not only acclimating them before the testing begins, but then the day of testing, putting them in, having them stand for a certain period of time, just to make sure that you're removing some of that residual movement of them either being curious or potentially not comfortable in there because it's a new experience. So if they're used to the enclosure, then you can get a more consistent reading.
Yeah, that's fantastic. And I really appreciate you sharing some of that information. And I think you hit on something really important in research as well, which is just that collaborative effort, right? Like phoning a friend, asking what other people are doing, I think goes a really long way. So I'm so glad that you mentioned that as well and that it was helpful. It's time for a quick break to hear about the JAALAS Learning Library. Hey, are you ready to elevate your team's knowledge and skills in laboratory animal science? Well, the JAALAS Learning Library is your one-stop solution for comprehensive training. With courses designed for everyone, you can train your entire team in one place, earn valuable JAALAS CEUs and RACE CE credits, and take advantage of group discounts to maximize that investment. Getting started is easy too. Sign up for free to access select courses instantly to explore a vast library of resources. Empower your team. Stay ahead of the field and grow with the JAALAS Learning Library, your trusted resource for laboratory animal science professionals. Okay, so tell us some more about your study design.
So for the study design itself, the animals were randomized. So when we ordered them, I ordered them in batches to perform them. And then just as I went in the facility that day, I just was like, these are the ones that we're going to do for this test. And then these are the ones we're going to do for this test. So they did come at separate time points. They weren't all in the facility at the same time. Naturally, as I'm performing the test, I'm not blinded to what I'm doing. So it was an unblinded study. But, I try to do my best to keep the animals themselves as random as possible. So I didn't handle any of the animals first and think, well, you're easier to hold. We're going to do the random stiletto test with you because I'm going to have to hold your back end and pinch your foot, right? So I didn't do any of that. But, I do feel pretty comfortable handling rats, which I think maybe helps me at least, which I kind of get into the discussion of my personal preference when performing these tests. Mm-hmm. Holding them, I find a little bit easier than waiting for them to stand still.
All right. Well, thank you for that. Really great discussion of just kind of the study design. And yes, it was really straightforward, which we can all appreciate, but I really do appreciate you taking us through that. So let's just jump right into results. We would love to know what you found, anything that surprised you one way or the other. Let us know.
Yeah. So I think what was most surprising is that the variation that we measured among the tests and between the two genetic backgrounds of rats was not significant. Because when I was performing them, I was like, oh, this random stiletto seems real consistent, at least like as I was doing it. And I think it was just based on my personal preference for the ease of performing the test. Because for the Hargraves or the tail flick test, you have to make sure that glass stage they're standing on, that the light's passing through, stays clean. So every time they urinate or defecate, you kind of have to move them. You got to clean up the glass and then you got to wait. So I don't know if it was just my internal frustrations getting to me while performing this test, but the true variation observed between the three was not significant, which in the grand scheme of things, I was happy to see, because that means that, from a statistics standpoint, there's no reason to choose one test over the other. And the same was true for the genetic background. I kind of initially thought, which I didn't mention earlier, was that an outbred rat has more genetic diversity compared to an inbred rat, which is more homogeneous. So an inbred rat like the Fischer, I thought, well, they got a lot of the same genes, same proteins. I'm sure their perception and reactions to a noxious stimulus will be more consistent, which was not shown when performing these tests, which I think could just speak to the complex nature of pain.
Sure.
We did have a small number of animals used for this study, but I think just as an initial, hey, let's compare these tests. No one's really described this. Let's get some of this information out there. It still provides useful information for people moving forward when kind of determining animal group sizes. But I think for me, the lack of difference in the variation was a little surprising at first, but at the end of the day, I was kind of happy that it didn't exist.
Right. Oh, that's so interesting. I definitely appreciate you kind of hitting the highlights there. That is indeed interesting. You're right. At first glance, you would think that what you hypothesized would be correct. So that's interesting. All right. So how about your discussion? You kind of alluded to a little bit of that. I'd love to hear a little more.
Yeah. So, it was kind of after we finished this project and what we intended to do, which was to answer a question of what would work best for us. We almost kind of used the discussion as a write-up of what we found were logistically some of the easy things about each of these tests, the difficult things. Of course, we discussed our results and potential variables that could cause differences in pain response, which are stress from handling, everything from light sources, male, female operators of the system. These have all been described in the literature as potential variables. But I kind of thought it'd be good to discuss, hey, if you're going to use the random stiletto test, you're going to have to hold the animals. You're going to feel comfortable holding the animals. That might not be ideal for you. And at the same time, if you're going to be doing the Hargraves test or the tail flick test, there's that glass stage. It's going to be more time consuming if they're going to be urinating or defecating. The potential for moving them around and cleaning. So for me, somebody who felt very comfortable holding a rat, I could do the random stiletto test much faster. At least I felt like I was being much faster. Granted, I had to do one at a time rather than you can put a couple animals on a stage and do the Hargraves test or tail flick test. But at the end of the day, I kind of used the discussion to say that, we chose some data to emphasize that we're not seeing a variation for these tests. So when it comes to future people who don't have a preference for their pain test yet, don't have, oh, I want to use a Fischer rat for this reason, or I want to use an SD rat for this reason. There's no reason to choose one over the other yet, from our data, to say why a certain pain test is more accurate than the other. So we're saying the main thing is if you have a certain research question and you want to use a thermal assay over a mechanical assay, right? So that's stimulus. We say kind of go for what fits your question and fits your comfort level. That would probably be the best to answer your specific research question. Because if you can do it well and reproduce it, that would probably make for the best science.
I really appreciate that. I just can't get over enough how excellent you're just kind of putting this all in practice and a practical kind of package for our listeners is. I really, really appreciate that. And thank you so much for sharing just kind of, hey, this is research in our hands and in our experience, if you were going to do the same thing, and I think sometimes we don't really ever discuss the sort of comfort level of, hey, are you at all comfortable or adept at handling rats in this way? This probably isn't the best test for you. I really appreciate that. And that's not something we see a lot in the literature. So thank you. I had a kind of a question for you too. I wondered if you had discussed the age of your subjects at all, and if you had considered any type of variation there coming from age.
So we used all the same aged animals. I can't not remember offhand what we used, but we definitely used sexually mature rats. I can't remember if we ordered them at 16 weeks or not, but it's definitely listed in the paper.
Yep, sure.
And we didn't want to add that as another variable at that time because we were already using this week apart assessment. We already had sex as a variable. We had genetic background as a variable. We had one of the tests as a variable that we weren't really wanting to put age on, but there is evidence and specifically anatomy and physiology of age-related differences for pain, specifically looking at like neonatal animals.
Yeah.
I don't know personally. I would have to look into it to see how, if this rat was 6 months old, 1 year old, how is that going to affect the pain response? But we chose an age based on a lot of the models we were seeing described in the literature. So things from spared nerve injury models to incisional pain models. We were trying to capture an age that people are commonly using for these studies, just so it could be most translatable to what's actually being done.
Sure. And I definitely really appreciate that. Maybe we just designed your next study. I don't know.
Yeah, maybe.
Let's throw some more variables in there. It sounds like you got a great platform to take on some more research there. So yeah, maybe that's your next one.
Maybe, yeah. Would be a good question to ask.
Well, I wish we could just talk about this all day. I really have enjoyed speaking with you. And again, just so impressed with how well you're able to get this study done. And you really are contributing to the body of literature here. And it's just really amazing. So we always ask our guests a final question. And it's always kind of the same. And it has something to do with advice. So for you, Jamie, we would love to know just kind of what advice would you give to somebody who is in their setting, is wanting to design a study that may be somewhat similar. They maybe have access to some different strains and they're really trying to figure out the best model potentially to use. What advice would you give them?
I think the first and foremost advice I would give, especially as you're developing a model, is kind of what's currently been done and what other people are using. I think that might help gear you toward, it's like, well, if all my collaborators are using this nociceptive test, right? This pain test, maybe I'm going to choose that one too. They're doing 2 for the same animal. I should probably be doing 2 as well. Maybe that's going to give me the most consistent data that could be more reproducible. And especially when it comes to genetic backgrounds, knowing if there's certain things that happen in certain strains, we kind of didn't get into it in the paper, but certain rats have different temperaments. So like a hooded rat's usually known to be very calm, very docile, very easy to handle. But if you're using like a Fischer rat, they're known to be a little bit more high strung. So considering some of the personalities, whether that be anecdotally or some of the true strain-related phenomenon, whether that be like an albino rat's going to have more propensity to have retinal damage with light, as just an example. Just a good thing to consider that you're picking the right model for your study. Now, more specific to the pain testing, and kind of what our findings from this paper show, it's that, when it comes to the level of variation, when you want to have a consistent reading that you can, quote unquote, trust that you're doing and getting from your equipment, what's comfortable for you, what you're able to do again and again, what you know how to do is what's going to be best for you, I think, especially looking at these 3 tests. I saw that the variation I was getting for these 3 assays, the Randall-Soletto, the Hargraves, and the tail flick, were similar across them. So that's showing me that I can, with the same accuracy, perform each of these tests, which at that point, I would just kind of pick the one I like the best and what I think is easiest for me. And that would be my advice to people too, when they're kind of coming up with these tests and what they want to implement into their studies.
Oh, that's great. And again, thanks to your paper that kind of gives us that assurance that really it probably is okay to pick the one that is the most comfortable and, for you, which is going to equate to better animal welfare and better research results anyway. So that's great. So thank you so much, Jamie. I'm sorry that we're at the end of our time, but I really appreciate you being here.
Of course.
You shed a lot of light on just kind of the nuts and bolts of setting up these pain testing modalities and how they can work in your own research lab, and I really appreciate that. I am excited. I think you've got a really bright future. I'm excited to see more research from you and your mentors, so everyone keep an eye out for that. Jamie's info will be in the show notes if you want to connect, talk thermal or mechanical pain sensitivities, and a collab. And we look forward to hearing more from you. Thank you so much, Jamie.
Oh, great. Thanks, Jenny. It was a pleasure.
Thanks for joining us on this episode of The Last Word. We'd love to hear your thoughts, so be sure to leave your feedback in the comments. And don't forget to subscribe for more great content. We encourage you to submit your research manuscripts to our journals, JAALAS and LAS Pro. We're always looking to feature impactful studies. You can also connect with us on our social media channels or email us directly at info@alas.org. We appreciate your listening today, and we'll see you next time on The Last Word, an ALAS podcast. Until then, stay curious and stay connected.